Guys, am I audible? Guys, am I audible? Okay, class. So let's wait for 5 minutes. So let's your friends can connect. And guys, this is your break, na? Class, this is your break. Ishita Shivkumar. Ishita. Is it your break? Ishita, is it your break? Class? Anyone? So class, let's have a break. Class, we are having a break of 10 minutes. So class, break for 10 minutes. Will continue at 10:50 a.m. Okay, so class, the second session would start at 10:50. Okay. Okay, class. Yeah, good morning. Good morning, Sudarshan. Good morning, guys. Class, am I audible? All of you? Guys, am I audible? Class, Ishita, Sudarshan, and many more. Class, am I audible? Sudarshan, Rupesh, Ashwita, Kirtika, Lalit, Kevin Krishna, Hari, Harshit, Praneet, Shruti, Devadarshini, Devpriya. Guys, am I audible? All of you? Okay, class. So your break is over. Now we are discussing about the BST. Okay, class. So till now, what we have done, we are discussing about the binary search tree. So what we have done, we have solved one question. The question is 700, which is find the root that has same value. But class, we have no that finding the something in BST class. Okay, let's. I have very interesting thing for you. Class, what the time complexity of this function? What the time complexity of this function? Anyone? Question number 700. What was the time complexity? Class, what was the time complexity? Guys, it's O of log n, not O of n. You can see that, na? You can see that in this, if we are finding 2, the 2 is less than 4. So we are never going to check this part. We are never going to check the right part. We are always going in the left. You can see now. We are moving in the height of a tree. We are moving in a height of a tree. So I could say that the time complexity is roughly the height of a binary search tree. What is the time complexity? The time complexity is equals to the height of a binary tree. Class, is it clear? Which is log n? Which is what? Log n. Okay, or the height of a the height of a BST. Okay, class. So this was the simple piece of code that we have done. Class, now the thing is we have done all the stuff. Okay, class. Now we have to see how can we create a binary search tree. How can we insert? Class, now we are going to what we have learned till now. What we have learned till now in BST. How can we traversals? And in the traversals, we learned that in order is sorted. In order is sorted in ascending order. Okay. Now what we have also learned that searching is easy. Searching is log n time complexity operation. It is similar to like binary search. Okay. Yes. Now what we are going to learn, how can we insert something and how can we delete something. Is it clear? How can we insert something and how can we delete something? Okay, class. So let's open our VS Code. So it would be very easy for us, guys. Give me a second. Okay, this is our VS Code. So let's open one more file. I am giving this in a BST binary search tree bst.cpp. Writing the basic piece of code. All you are aware of it. There is no rocket science. Bits/stdc using namespace std main return 0. Okay. So first of all, let's create one class. I'm calling this class as a node basically, or maybe let's give them a name as a tree node. We are following the same convention. So it has int what data, then two pointers left and right. Okay. Now what we need a constructor. So and this constructor, there is a value when you pass it. So the data is this value and left is equals to null and right is also equals to null. And there should be semicolon somewhere someone pointed out. Okay. So class, now we are creating a BST. Just we have how we know that how can we create a so I'm don't know but I'm taking values. Let's create a BST of size 10. So what can I do? What can I do? I could take that I am creating a BST of size 10. I'm creating a BST of size 10. We could do what? Achha, we would be creating it by is there any question? It would be very easy for us. So if sir, please increase the okay. Sir, please increase the size of VS code. Okay, 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 okay. Is it visible now? Priyadarshini, is it visible? Guys, is it visible now? So class, we are creating one function. How can we insert? So after inserting, we are passing the root. So I am just creating or insert. I'm just writing this function as an insert. So in this, what we are doing, what we are passing class, what we are passing in this. If we are creating, we have to pass the root and we have to pass that value that we are inserting. So this is our tree. In this, we want to insert any value. If there is no tree, this root would be null, and I want to insert this value. Okay. Okay. So class, what is the first step? We check whether the root exists or not. If there is no root, means I have to create a root and assign that value to it. So okay, we could do that. Return simply what return new tree node and of this value and return it directly. What is inaccessible? Return new glass. Give me a second. There is someone at the door. Okay, class. Sorry for this disturbance. There was someone at the gate. So, class, we are creating a value from it. Okay, if root doesn't exist, class. Suppose if there is no tree, we are passing this root which is initially null, and we are passing this 50. So there is nothing. So we would be creating one root from 50, and we are returning this. Okay. Now what next? So let's write the function one by one. So we are creating one root which is initially what? Null. There is nothing. Okay. There is nothing initially. And now what? It is returning something. So we are calling one function root insert the value 50. Insert the value 50. Okay. Insert the value 50. So 50 has been inserted. Now we are inserting some more values, and what values we are inserting. Okay. So what can we say that? Insert root, insert root. Now we are inserting 30. Okay, class. Now we are inserting 30. Yes, now if we are inserting 30, the 30 would be present somewhere here. The 30 would be present somewhere here. Okay. Now if I am inserting, if numbers are coming like this way, 50, 30, 20, 40, 60, 80. So class, now 50 is there is no tree. I am creating 50 as my root node. Then 30 is there. I would be creating this 30 as the left child. Now again there is 20. Again the 20 would be the left child of this 30. Now 40. Now 40 is less than 50, but 40 is greater than 30, so it would be the right child of this 30. Now we are at 60. The 60 is greater than 50, so it is similarly, it would be present here. 80 is greater than 60, so it would be like this. So we are creating such type of BST. If we are following, if we are having this type of what? I'm getting this type of tree we are making. So let's write this line again and again. So we are inserting this thing. So it is 50, 30, 20, 40, then we have 60, then we have 50, sorry, 80, and let's make it 55. So let's write the function here. Now what we are going to do? We are going to check. So how we are going to check? We are checking this input value with the help of this roots value. So we are going to make the check. We are going to make the check. We want to check if the value which is given to us, it is less than what? Roots value. It's roots data because it is written as data. Yes. If the value is less than what? Roots data. So what could I say that? What would I say that? In the roots left, call this function. In the roots left, call this function. So I would go in the root left, call this function. In the root left, call this function. Why we are getting this error? Okay. It should be public class. By default, it is. Yes, why we are writing public? Because by default, the access modifier is set private in C++, so we have to write this public here. Okay. If roots value is less than, go to the left of it. Okay, that's pretty cool. Now, if it is greater, then do what? Go to the roots right and call the same function in the roots right and pass the value. Pass the value. Okay. In the end, return root. In the end, return. Just for the sake of understanding, we should write one print function. So we could easily find the print function. So it would be easy whether we are creating the same tree. So I am creating the in order traversal. So we are getting a what? We are getting a what? A shorted output. We are getting a shorted output. We are getting a shorted output. If root is null, return do nothing. Spelling mistake. Okay, then do what? Do the in order traversal in the roots left. See out roots data in order traversal root right. Okay, so if we are so we could try it like this. See out in order traversal for the root. So it would be easy for us. Okay. So if I try to write this, we are getting the same output or not? So 20, 30, 40, 50, 55, 60, 80. You can see now, we are getting a tree as it's intended. We are getting our input as intended. So this was for just for the sake of whether our we are creating tree right or not. So this is the function. How can we create, how can we insert anything in our binary search tree using simple method? If it is smaller, it would be go on the left. If it is bigger, it would always go on the right. Class, this is clear na? A simple basic thing. Right? All of you true if this is clear. Because class, I am going this thing little bit faster because I have some questions in my mind that I have to do. Okay. Class, is it clear? Right? True, all of you in the chat box. This is clear. Okay, this is clear. If how can we create something? Okay, class. So insertion was quite a easy thing. Insertion was quite a easy thing. So we are creating this. So 55 would be presented here. है ना? So let's create one more BST. Let's take this binary search tree. Let's copy this binary search tree that we have created. 50, 30, 20, 40, 60, 55, 80. Yes, now we are discussing that insertion has been completed. Now we are discussing deletion. How can we delete any value in a binary search tree? Because why in the binary search tree? Because in binary search tree, there is a condition that needs to be followed always. So we are going to, the deletion is little bit more complex. So we are going to think that how can we solve it? Okay. Okay. Yes, now suppose, now class clearly suppose that